Welcome back to Daily Dose of Space. The universe looks calm from a distance. Galaxies drift slowly, stars shine steadily, and nothing seems urgent. But this calm is an illusion. Because from time to time, the universe releases an amount of energy so extreme that it briefly becomes brighter than entire galaxies combined. An event so violent that space itself reacts. An event that for a few seconds pushes physics to its absolute limits. This is not science fiction, and it is not ancient history. It is happening right now, somewhere in the universe. When the universe screams. Most cosmic events unfold slowly. Stars live for billions of years. Galaxies evolve over unimaginable timescales. But the most violent events in the universe do the opposite. They happen almost instantly. A sudden flash appears in the data. It lasts seconds, sometimes less. Then it vanishes completely. When astronomers first detected these flashes, they didn't know what to make of them. The signals were so powerful that they triggered military satellites designed to detect nuclear explosions on Earth. It took years to realize the truth. These flashes were not coming from our planet. They were coming from across the universe. More energy than a star can give. These events are called gamma-ray bursts, and the numbers associated with them are difficult to even describe. In just a few seconds, a single burst can release more energy than the sun will emit over its entire lifetime. Not metaphorically. Literally. And this energy is not released gently or evenly. It is focused into narrow beams, moving outward at nearly the speed of light. Most of the time, those beams are not aimed at us. When they are, we notice. Even from billions of light years away, these bursts briefly dominate the entire sky in gamma radiation. Distance barely matters when the power is this extreme. How a star dies the wrong way. Some gamma-ray bursts begin with stars that were never meant to live long lives. These stars are enormous, unstable, and short-lived from the moment they form. They burn through their fuel at an incredible rate, growing hotter and more chaotic as they age. When such a star collapses, it does not produce a normal supernova. Its core collapses directly into a black hole. As matter falls inward, it does not disappear quietly. It forms a swirling disk around the newborn black hole, twisting magnetic fields into structures powerful enough to launch jets of energy through the star's poles. When those jets escape the star, the gamma-ray burst is born. For a brief moment, the death of a single star becomes one of the brightest events the universe can produce. Collisions that bend reality. Not all gamma-ray bursts come from stars dying alone. Some come from collisions. Neutron stars are the remnants of massive stars, crushed into objects so dense that their gravity distorts space itself. When two neutron stars orbit each other, they slowly lose energy, spiraling inward over millions of years. The final moments happen fast. As they collide, space-time ripples outward in the form of gravitational waves. At the same time, a burst of gamma radiation is released into the universe. For the first time in human history, we can now detect both signals from the same event. We can feel the vibration of space and see the flash of energy. These collisions are also responsible for creating some of the heaviest elements in the universe. Gold, platinum, and many rare elements owe their existence to moments of extreme violence. The universe at its limit. Gamma-ray bursts are not just violent, they represent a boundary. They occur at energy levels so extreme that our current understanding of physics starts to strain. Magnetic fields trillions of times stronger than anything on Earth. Particles accelerated to energies that no human-made machine can reach. In these environments, matter behaves in unfamiliar ways. The rules we rely on still apply, but they are pushed to their edge. This is why scientists study these events so intensely. They are not just explosions. They are natural experiments conducted by the universe itself. A quiet threat that passed before. There is an uncomfortable truth hidden in all of this. Gamma-ray bursts are rare, but they are not harmless. If one occurred close enough to Earth and was aimed directly at us, it could severely damage our atmosphere. Not through impact or heat, but through radiation. Some scientists believe that a gamma-ray burst may have contributed to at least one mass extinction in Earth's distant past. There is no panic in this realization. The universe is vast, and such alignments are extremely unlikely. But it is a reminder, violence on this scale exists, and it does not announce itself in advance. Seeing the early universe through destruction. Ironically, these destructive events help us see farther than almost anything else. Some gamma-ray bursts come from the early universe, when the first generations of stars were forming. Their light travels across billions of years, carrying information about ancient cosmic conditions. By studying these bursts, astronomers learn about star formation, galaxy evolution, and the structure of space itself at times we cannot observe directly. The universe reveals its past not only through creation, but through destruction. Why nothing else comes close. There are many powerful events in the universe: supernovae, quasars, black hole mergers. But none of them combine speed, intensity, and raw energy the way gamma-ray bursts do. They are brief enough to feel unreal, powerful enough to rewrite entire regions of space, rare enough to remain mysterious. They are not just the most violent events since the Big Bang. They are reminders that the universe is capable of extremes beyond intuition. The universe does not explode often, but when it does so without compromise. Gamma-ray bursts are moments when the universe reveals how much power it can unleash in absolute silence. They last only seconds, but their consequences echo across billions of years. Thanks for watching Daily Dose of Space.